Hello! So if you remember in the last video, I showed you how to load a piece of data into R. And if you notice, I tried to do it the long way around, the more controlled way of doing it. The simple way of doing it would just be to go up here to Session, Set Working Directory, and then choose the file which you want to load in. Okay, and then you can just simply use the read table command, which I showed you here. But I actually showed you how to specify this exactly where the file is. And the reason for doing that is when I'm working with data, I'm often working with data which is saved in different locations because it makes sense on my computer to save it in different folders, for example. So by doing it this way, you just have more control over where that data actually is. And if you remember, the data which we're looking at is information about bodybuilders. And we looked at the text file and it's kind of all jumbled up and we couldn't really extract much information from it. It's really difficult to read. But R doesn't mind if we just click BB, okay, which is the name of my data, which I've given the name of my data. And then you can see it's just formatted it nicely into proper rows and proper columns and things. And yeah, it just looks nice in R. So now, whenever I first load in a piece of data, which I haven't seen before, into R, first things first, which I do, is I just want to get a general feel of what that data is all about. So the function which I use is summary. Really nice function. So I do summary of my data set, which is BB, and it just loads up some basic statistical analysis. So for example, for the weights, it tells me that the minimum value was 57.3 and the maximum value was 747. That means that I can really easily work out the range just by doing the minimum take away, so the maximum take away the minimum take away from the maximum. Same thing with the quartiles. I've got the first quartile is 73.7 and third quartile is 87.8. That means I can work out the interquartile range by taking the first quartile away from the third quartile. I've got the median and I've got the mean as well. And it's done that for every single category, every single column within the data. Really, really nice just to get a general feel of what the data is all about. Notice as well that, for example, with the urine.pH, it's told me that the number of NAs is 2. Now, for those of you that aren't really familiar with NAs, with working with data, if you've got data which is missing, they just put an NA there. It just tells whoever's working with the data that there's data missing there. It's just NA, okay? You notice there's some more NAs sort of down here. Now, why is this an issue? Well, let's say, for example, I just want to pull out the weight section of the data. So I just want to pull out all of the values that are the weights, okay? So I just go, the way which I do that in R is I say, this is the data set which I'm using, which is BB, and then I tell it to pull out the weight section of the data. So I use the dollar symbol and then just type weight. Okay, and then that will return me a vector of all of the values which are the weights. And now I can do things like the mean. So the mean function applied to BB dollar weight, and then that will return me the mean is 93.771 effectively, which is what it was up there. Now, if I do the same thing where there's an NA, so for example, the urine, I do BB, that's the data set, dollar, tell it to pull out the urine.pH section of that data set. And you notice that I've got values for all of the urine readings, but you notice here I've got a couple of NAs. So the fact they're next to each other is just coincidence. Every time there's an NA, there's basically data missing. Okay, so now, for example, if I do the mean of that section of the data, so BB dollar urine.pH, it needs to be capital BB, okay, and click enter, it returns me NA, because what it's doing, how you work out the means, you add all the values up, then divide them by the number which you've got. What it's doing is R is reading those NAs, and it's thinking, well, what do I do with these? I don't know how to add a value to an NA, okay? It doesn't know to ignore them, which we think it should do. Fortunately, there's a really nice function which will be able to work with this, and it's called na.omit. So if I do the mean of, and I apply na.omit to this, so I do na.omit, all lowercase, of the data where there's NAs, which is BB dollar urine.pH, yeah, BB dollar urine.pH, oops, pH. Return that. That now returns me the value 5.92 or 93 effectively. There you go, which is the same as the mean up there. So basically, when I do the summary, it automatically excludes the NAs. It's automatically told to exclude the NAs. But if you want to actually work with the data, the na.omit is really, really useful. Okay, I can do various other things with this as well. So for example, if I want to try and visualize the data, R has got a really powerful graphics package within this software. So it's really good at visualizing things like plots and graphs and things like that. So for example, if I want to just do a histogram of the weight section of the data, so I do BB dollar weight, okay, click that, and it comes up with a histogram, which I think is just behind my head, of the histogram of the weights. Okay, if I do the same thing with histogram of, again, same kind of problem with the NAs, I think. So if I just do BB dollar urine.pH, where there should be NAs, Oh, it doesn't matter actually with the NAs for that. So basically, you've got some really good, powerful statistical analysis within R. Okay, so you load a piece of data in, then you can do all sorts of different functions, and actually, it's really worthwhile digging further. It's just some basic analysis for statistics, fantastic, but there's also more advanced statistical analysis which you can do as well.